Today we are going to discuss about the another important protocol that is called TCP. So transmission control protocol. In the last class already we have discussed about the UDP, user datagram protocol. UDP offers connection less service, whereas TCP offers connection oriented reliable service. So even header wise also, if you see here, you need more header. Why? Because it is going to offer connection oriented service with reliability. So now if you see the details of TCP, first we will see the some introduction part of TCP, then TCP service model, TCP protocol, TCP segment header, how header looks like. After that we are going to discuss about connection establishment and release of connection, how can you manage the connection, and the TCP transmission policy. When you want to transfer the data from one place to other place, transmission policy plays a vital role. TCP congestion control. Suppose during this congestion happened, how you are going to resolve that condition, and TCP timer management. When you start transmitting segments from one place to other place, how do you manage these timers? So that is the discussion of TCP time management. So these are all the discussions related to the TCP. So when you see the port numbers already during the discussion of UDP and socket discussion, we have seen socket is nothing but combination of IP address and port address. Suppose you see the certain applications, port numbers are fixed. So other applications you can assign port numbers, and if you see this one file transfer application, port number 20 and 21 you can use. Like that remote login case you can use 22. Your standard email SMTP we use port number 25. Suppose you are working with World Wide Web HTTP, we are using 80 port number. And remote email access, that is the post office protocol 3, we are going to use port number 110. Remote email access, another possibility, we are going to use 143 port number. And like this different port numbers we are using for different applications. So certain applications port numbers are fixed. Suppose Gmail SMTP protocol, port number 25 is always fixed. The same way World Wide Web accessing, port number 80 is fixed. So these are the some assigned port numbers. Apart from this, you can assign the port numbers for other applications. Now coming to the segment handling, suppose you have a data at the application layer that is taken care by the transport layer to transport the data from one place to other place. Here that data is available as 4 512 byte segments like this A, B and C and D. So this first this one is the indication of TCP header, this one is the indication of IP header. Like this A, B, C, D, 4 segments are transmitted from one place to other place, and at the other end these are all A, B, C, D combined. We say 2048 bytes of data delivered to the application in a single read call. So all 4 you can read at other end. So this is the way we can transmit segments from one place to other place, and we can read as a single call also at receiving end. Coming to the TCP segment header, already we have seen UDP header. There if you see UDP header point of view, you have only 64 bits are possible. Why? Because 32 bits to pull and 32 bits. So making 64 bits is the header size of the UDP. Whereas when you come to the TCP segment header, here fixed size, if you see, this is this row 32 bit, this row 32 bit, this row 32 bit, this row 32 bit, and this row also 32 bit. Total 1, 2, 3, 4, 5. 5 32 bits making 160 bits. 160 divided by 8 if you do, you'll get bytes. So it is nothing but 20 bytes is the fixed header here. This 20 bytes is the fixed header, you cannot change here. For all the segments, whatever the segments you are going to transmit, this 20 bytes header is the fixed one. Whereas this one is the optional header. You can add more number of header bits as per the requirement for additional purposes. After that, we are going to add actual data. We say payload is added here. So this is the understanding of TCP segment header. Now our discussion, we are going to discuss about basically this header, 20 bytes fixed header. Now if you see the first one, anyway, when you see the socket, there are two addresses you have to mention. One is port address, and the one is the IP address. So IP header case, there IP address is taken care by the IP header. Here your transport layer header is dealing with the source port address as well as destination port address, 16-bit source port address as well as 16-bit destination port address. So coming to the next field, sequence number, when you are transmitting the segments from one place to other place, you want to distinguish one segment, another segment, and we need sequence number so that you can differentiate. At the same time, you want to acknowledgement also, you have to use this one, sequence number as well as acknowledgement number. So that is the purpose of sequence number, acknowledgement number. Why? Because this is the connection oriented service as well as reliable service also. Coming to the next 4-bit field, this is the TCP header length. So your TCP header length, 4 bits is the indication, minimum value 0, maximum value is 15. And if you multiply with 15 with 4, you will get 60. So that is the thing, you are saying that the 20 bytes is the maximum possibility, and this is the optional data. If you add, it is up to maximum of 60 bytes, whereas 20 bytes is the fixed header. Remaining 40 bytes you can add here, so making 60 bytes. So that is the reason we are fixing TCP header length as 4 bits, but the minimum value should be 5. So that is the reason 5 into 4, if you do, you'll get 20 bytes is the fixed header, remaining 40 bytes is the optional header, making maximum 60 bytes. This is the unused one. These are single bit, these things 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 4, 12, remaining 4 bits unused. So what is this CWR? This is the indication congestion window reduced. So when congestion happened, generally we know we will transmit, we will indicate that congestion happening with the alpha of explicit congestion notification, we say. So there we say explicit congestion notification. So we say ECN echo we transmit, that is the ECN echo we transmit, indication congestion is happened. So that is the reason we are using these 2 bits in the header. So congestion window reduced as well as explicit congestion notification echo we are transmitting. What about the remaining 6 flags? If you see, this is the urgent flag. Urgent flag set means from this urgent pointer onwards, you have to submit data immediately to the top layer, that is the application layer. So that is the use of urgent pointer. This urgent flag is set 1. Then from this point onwards, you have to submit whatever the data you have received to the boss immediately. And anyway, acknowledgement number is valid or not valid. For that purpose we are using acknowledgement. This push generally we use to push up the data, and this reset will use whenever you want to terminate connection abruptly. Then we are going to use this RST, that is the reset option. And synchronization, when you want to establish connection, and this one we are going to use synchronization. So why? Because sender and receiver should be synchronized so that we can establish connection. And finish bit, end of the connection, we are going to use this finish bit, so we can release the connection. So these are all the flags indication. Now this is the window size indication. What is the maximum window size possibility? We are using 16 bits possibility, so that is the maximum size of window size. Anyway, checksum is needed. to verify whether the received data is right or wrong. Nothing but received segment is right or wrong. Suppose it is wrong, we can intimate to the sender so that you can retransmit once again. So that is the function of this checksum. Remaining things are the optional fields, and anyway you need payload. That payload is added here. So this is the discussion of TCP segment header. Already we have seen the discussion of reset bit is used to abruptly reset a connection, and synchronization is used to connection request connection accepted. For that purpose we are using synchronization bit. Finish bit is used to release a connection. It specifies that the sender has no more data to transmit. However, after closing a connection, the closing process may continue to receive data indefinitely. Both sync and finish segments have sequence numbers and are thus guaranteed to be processed in the correct order. So, this is the discussion of TCP header point of view. Thank you for your attention. Remaining things we will see in the next class. That is also continuation of TCP discussion. Now at present we have discussed only uh, TCP header point of one. So remaining things will continue in the next class. Thank you.